finding the input impedance with the cap. So for without the cap, you generally allow the radiation resistance to be present. With the cap, you confine it within the near field region only. You eliminate any question for radiation resistance. You only take up the loss terms. So naturally, you can segregate. This actually is a technique, is a roundabout technique of confining the region and finding the losses separately, uniquely determining the losses, and in some cases the radiation resistance. So the input impedance, real part, imaginary part, you can get it. The real part of input impedance, real part with the cap, and the input impedance in free space. Now the two relations. Now if you can go for this using the series RLC, you model the antenna with a series RLC, this relationship is fine for you. Just flip the equation. If you want to, you can model with the parallel RLC. Generally, most of you generally go for planar antenna systems. So microstrip antennas, we can tell that with the latest, very recently in 2013 and 14, people have again come up because there was a balancing act. Now some researchers in the earlier domain, they told that, okay, the series RLC is a good equivalent circuit for a single frequency patch antenna. Then people again told that, okay, we can see that we have always find that series RLC is good, but later on when they wanted to determine the antenna efficiency Q, they found that, okay, the parallel RLC model was suitable. So that was more accurate. So the latest information is only that it's parallel RLC model is suitable. Now, when you do so, keep in mind that this particular information is for a single frequency or a unique frequency radiating microstrip antenna, having no other modes, no higher modes. No, there's no other frequency in the vicinity. If you are going for multiple mode or multi-band antenna systems, you have designed an antenna patch antenna which is multi-band and you want to find it within this, you have to take up its equivalent circuit for different RLC, find the net input impedance, calculate it, and then. So this exact relation, only making a single RLC parallel network, and then will not work. So you have to modify the equivalent circuit and recalculate what is the input impedance. The shape of the conducting cap is not critical. Spherical can be taken, hemisphere can be taken, and it can be cylindrical also. The radius is generally lambda by 2 pi. The cap has to make good electrical contact with the ground when you put it. In fact, you can take any steel container, a 500 grams steel container for baby foods, that is it's made of tin, so it's good for most of the patch antennas and electrically small antennas, small compact antennas you are designing, but keep the ground plane such that it touches the edges of the inverted tin container properly. I hope you understand this fact, because you can try to work with it recollecting this figure. So the ground plane should exactly touch the container. It is not necessary that the antenna should be exactly placed in the center, a little bit of tuned value, and again the height and the radius, little bit tuning is required. The thickness of the container, it should be following the skin depth,